let's move on to exploring data. And the very first thing we're going to do here is load some data into Stata that came with Stata, sort of a pre-loaded or at least included with Stata, and it's ready to be loaded. So we're going to use sysuse, just calls them one of these. There are a few of these files that are included, and you can just type auto, or you could get in the habit of typing the name of the data set and then the type of data it is, Stata data file, so it's .dta, and then typing comma space clear. If we did not use comma space clear here, whether we included .dta or not, and we tried to load this, in most cases we would actually have an issue. Stata would say, well, excuse me for a second, but what you are doing is trying to load a new data set, and if I do that, then it will overwrite a data set that has already been loaded, and I'm not sure that you really want to do that. So unless you tell me for certain that you want to clear the old data set to load the new one, I'm not going to let you do that. So in general, you're going to want to type, well, you'll type use whatever it is, if it's not one of these included data files, auto dta comma clear. Now look at each of the sections of Stata here. We already said, okay, look, we see that these commands are here. We can double click on them, or we can use Control R. We can scroll back up and see what we've done, and that might be something that we want to do if we're just exploring the data very briefly, and we want to try something similar to something we tried before, or the same now that we've cleaned it slightly differently before we actually enter stuff into our do file. So that can be quite useful. If we look over here, and I'll make this larger so we can see all of these, we have the name and labels included for these variables. Now, make, the variable make is selected right now, and if you look right below, we can see, okay, great, make, and its label, make and model, the same as up here. Here, though, we are told the type of variable it is, str18, string 18. If we instead clicked on, for example, price, we'd see the type is actually an integer rather than a string. Mileage the same way, per record the same way. If we go down to foreign, it's a byte. Label is car type, and we're going to see that even though the label says car type, there are actually labels for the individual values that foreign can take as well, and that's going to be useful. If we look down below that section, we can see sort of the metadata for this data set called auto.dta. This data set is 1978 automobile data. It has 12 variables, 74 observations. It's 3.11K in size, and importantly, we can see that it's sorted by foreign. And we'll see later on how sorting can make a difference, especially tomorrow we'll see that. But in a general sense, it's just good to know how your data are sorted. And it's worth keeping in mind that resorting your data can change the way that Stata does things, and you can get different results if you are not clear on sorting things the appropriate way. So just keep that in mind. Now we already clicked on the variables make and price and figured out what type they were, saw how many variables and observations were in the data set. One thing we didn't do was open the data editor. So if you go up here, there are two types of data editors. You can edit or you can just browse. I do not edit my data by clicking this and going into the data editor. I don't often use the data editor even to browse either, but it is worth taking a look at least once the very first time you load a new data set, just to get a sense of what is going on here. And what we can see is we have make, and it's a bunch of makes and models of cars, just like the label told us. We have, for example, prices, miles per gallon, etc., etc. Now, one thing that's worth noting, repair 78, or rep 78, we have little periods occasionally. So we have, in fact, for observation 3, what is currently observation 3, observation 7, observation 45, observation 52, and observation 64. Instead of having numeric entries, we have a period or a dot, and what that actually means is that those observations are missing for rep 78, and we'll see why that's important, but in general it's worth just taking note every time you load a new data set of those sorts of things. Now let's try a few new commands. Let's first try describes. You can just shorten it to D, or you can go describe. I often do DESC. What does this do? Well, it tells us essentially everything that we learned by looking through all this and looking through all this, etc. We have 74 observations, 12 variables, and we have the size. We have the date that this was last modified, or the date that it was loaded. We have down here the names of all the variables and descriptions of them, their type in particular, and the variable labels. And it can be very worthwhile to do this at the beginning of using a data set and just get a sense of what we're working with in terms of every variable, rather than clicking through each of them individually. Just doing this tells us, okay, well, we know that we have a string in the variable make, and the rest are some form of numeric variables. We can also, now I'll just do it by itself, say describe just one variable, for example make, and we don't get the sort of metadata, we just get a description of the individual variable. Let's try dir and pwd. So dir, if we type dir, what we're going to get is a list of all of the files that exist in our current working directory. And you can change a working directory, but right now the directory that we are in, it contains these things for me. It's going to contain different things for you. Now, what is that working directory? Well, Stata is going to have some standard one that it defaults to. You can change that default working directory, but in general you're not going to want to work out of there anyway. You can do different things like change it in each time using the cd space command, or you can actually do better, and we'll get to that later on. But just for now, let's see, well, what is the working directory? For me, this is it. For you, it's going to be something different. What else do we want to try doing? Well, if we clear, we lose all the data. You can see there's nothing left here. And if we do that, then we cannot actually, for example, get anything if we try to describe it, because it's gone. So we get nothing else. And we already talked about how commands need to come before any sort of text that we want to write, so we won't go over that again. Now, a few more basic commands. We're going to actually have to reload our data. So sysuse auto.dta, space clear. And now let's try doing browse summarize. So browse will actually just bring up the browse data editor. We already went over that, but if you prefer to type rather than going up and clicking on it and you want to see it, that's a good way to do it. Now, summarize. You can summarize. I actually tend to just use sum, but we'll type out all summarize. You can just summarize your entire data set at the very beginning, and it's in some ways similar to describe in that it lists your variable names, but beyond that you're learning very different things about each variable. It doesn't tell you, for example, the type, or at least not directly, but you can learn a few things, and certainly you're getting other information here. So let's start with obs. We know that there are 74 observations contained within this data set, and everything seems to have 74 except for rep 78 and make. Make has 0, it says, and rep 78 has 69. Now keep in mind here, rep 78, we had 5 missing observations. We looked through it, those periods, the dots, that represents a missing Stata, and so even though there are 74 total observations, rep 78 is missing 5 of them. So that's why that number is not the full 74. And this is actually something that we'll see a bit later is important to take note of and to take into account when we're performing certain operations. Now make. Why is make 0? We actually saw before, and we can try just doing the command list, which can also be shortened to L, but I always do list. If we, rather than list everything, if we just do list make, we can see there are actually things recorded or observed for make. Every observation is non-missing. And rather than hitting spacebar here or clicking more, we can hit Q, or we could break, pressing this button up here to stop showing all of these. Let's scroll back up here. Even though we have non-missing observations, it says we have 0 observations for make. And the reason is, if you recall the type of variable that make is, this is a non-numeric variable, it's a string. So with summarize, we're asking for summary statistics. You ask for the mean or the standard deviation, the min or the max of some string of characters, and it's not going to make any sense. You know, what is the mean of AMC Concord, AMC Pacer, and AMC Spirit? It's a nonsensical question. And because of that, we are not going to get much out of this. Now, I will note that, for example, foreign has 74 observations, and I won't get into this quite yet, other than to say if you list foreign, you're also going to see what appear to be strings. This is something to keep in mind for later, but the point being here is that you cannot simply conclude that just because we see some string included here that therefore it's a non-numeric variable. Clearly foreign has 74 observations. We have a mean, a standard deviation, a min, and a max. But it doesn't become immediately clear just when we list. So you do want to look at the type of variable or hit describe to see that. Let's sum price and then sum price with detail. So rather than summing all of them, we're just going to sum one variable, price. We see, okay, 74 observations, great, nothing missing. We have 61.65 for the mean, $29.49 for the standard deviation, min nearly $3,300 and max nearly $16,000. Now, we said we don't have any missing observations because, well, we have 74 here, and Stata does treat missings if they are truly missing in whatever the data are. If there's just nothing recorded, it records them as a dot or a period. But it is worth keeping in mind that a lot of data sets may not record your data this way. So if there's something missing, it may, rather than just leaving it empty or recording as a period, it may be recorded in this data set as, for example, 99999 or 99998 or -3 or something that just should not make sense as an actual value for this variable. But it's important that you actually know what is done in your data. If you do not know that, for example, missings are recorded as 99999, and then you hit mean, or you type sum of that variable and you look at the mean, you may mistakenly be including missings that are recorded as 99999 in your calculations of the mean and the standard deviation, etc. And this would actually introduce a lot of error in your calculations. So you do need to make sure that you understand how your missings are recorded, and for any variable that does record them without a dot, you need to recode them, and we'll get to recoding tomorrow. Just keep that in mind. Now, if we want to get more than just these summary statistics, we can use the detail option on summarize. I just often use D. And here we can see that we have the same variables, or sorry, the same summary statistics that we got from simply summarizing. We know we have 74 observations, the mean standard deviation, but we also get more. So for example, rather than just showing the min and the max, we actually get the 4 smallest and the 4 largest values. So the smallest of the 4 smallest is obviously going to be the min, and the largest of the 4 largest is obviously going to be the max, but we're going to get a chance to see what other values this variable takes at the extremes. You also get to see the percentile values. So if you're in the first percentile, it means 99% of the observations are higher than you, or 99% of observations are going to be higher than this value. If you're at the 99th percentile, then only 1% of observations are going to be higher than this, or none. And if you're at the 50th percentile, you are actually going to be at the median, which is what the 50th percentile is, or the median is the 50th percentile. Moving on. Say we use the list command. We get a lot of stuff. As I said earlier, we can hit space, or we can click more here. Maybe this is a little tedious. So let's hit Q to break it. And now let's try set more off. And if we hit list again, or type list again, oh, we've gone down to the very bottom. So we know there's 74 observations, and we're seeing all of them. Now, in general, you are not going to want to set more off before you run certain things, because you will often have far more than 74 observations, and if you go through all of them, if you list with set more off, for example, it can take quite a while if you have, say, 7 million observations to go through. So I do not tend to set more off. I keep it on, but that's a matter of preference, and you can do however you like. I said earlier we can use just L instead of list for list. I don't like to do that because it actually kind of looks a bit like a 1, and that might be a little confusing either to you or to other people if they're looking at your code. But if you want to do that, then you can. Say we have set more on or set more off, it doesn't really matter, but we only actually want to see the first 10 observations. So say we want to see price, let's do make price and rep 78. We want to see in the first 10 observations, we're going to do in 1/10, and there we go. We don't have to worry about anything else coming up. Maybe we don't want to see it in 1 to 10, maybe we want to see it 11 to 20. We just in 11/20, and there you go. We can also shorten our variable names. So we know that, for example, we have an interest in make price and let's say miles per gallon. We could say, as we were before, list make price miles per gallon in 1 to 10. Great, but maybe we're getting lazy and we want to do list MA, P, and MP. Now why have I done this? Well, there's only one variable that starts with P, it's price, and so P is enough to uniquely identify it, and Stata is smart enough to figure that out. With make and miles per gallon, however, they both start with M. They're the only two that start with M, the only two variables, so Stata knows that it's got to be one of those variables that we're interested in if we just included an M, but it wouldn't know which one. So we have to give it a bit more. We have to uniquely identify each of the variables. In this case, MA and MP are enough to do it, and if we hit enter, we can see that we get everything that we want. Maybe you have many variables that start with M, or you don't know what all of them are. You don't want to go and find out, okay, what's the second letter for each one. You just want all of them to be shown for whatever reason. Maybe you have a number of variables called, for example, make 1, make 2, make 3, make 4, and you want all of them to show. Well, you can just type list. You can do M star. What that's going to tell Stata is list all the variables that begin with whatever precedes the star. So in this case, M, and then sure, let's include the price. And we see here the order that they're displayed has been changed now. It goes in alphabetical, MA and MP, but it shows all of the variables that start with M and then price. I hit Q to break that. Maybe we want to sort things a little differently. So we said earlier that we were sorting on foreign, and that's how it loads. Maybe we want to sort on price, miles per gallon, and rep 78 instead. So keep in mind here, we've got AMC, AMC, and AMC as 1, 2, 3. Clearly it looks like in general, we haven't just sorted on foreign, we're also sorting on make. Now, it wasn't listed as that being the case, but it is true that things are sorted by make here. However, if we sort, you can do SO or full sort on price, miles per gallon, MPG, and rep 78. And you again list M star and price as we said. We can even include rep 78. Let's just do that in 1 to 20. Then we see, unlike up here, where AMC Concord was number 1, it's actually a Mercury Zephyr that is now the first observation. Now it hasn't just done that, we've actually told it to sort on price, and then on miles per gallon, and then finally on rep 78. So everything here that we see in the price column should be going from lowest to highest because the entire data set has been sorted on price. And in fact, even though we haven't looked at it yet, it is true that there are no dual observations of price. Every price observed is unique in this data set, so we did not end up sorting first on price and then on other things within price because they're only unique prices. But if we had not done that, then we would have seen something a little different. For example, let's sort on miles per gallon and then on price, and maybe rep 78. That's listing 1 to 10 now. What we can see here, we sorted on miles per gallon first, is that now everything is going from lowest to highest in miles per gallon, but we do not have unique values for miles per gallon. There are a number of observed values for miles per gallon that are duplicated for different cars. So within 12, the lowest miles per gallon, it then sorted on price. We can see that that's the case here. Within 14, it again sorted on price. So miles per gallon first, and then within miles per gallon, sorting on price. And if we had common instances of price, then within those it would sort on rep 78. But as we said, price is unique to every car here. Let's try a new command, the tabulate command, and we can shorten that to tab. So it's tab make. We can see when we tab make that we have 74 total observations, and each make is unique, which makes sense. In fact, the units of observation that are probably the most obvious for this data set would be make, and so for each individual make and model, we are getting all of the other variables. So we get the number, for frequency, of each one. We then get the percent that makes up of the entire data set, in which case we can double check it. So 1 divided by 74 equals 1.33% or 1.35%. And then the cumulative percentage. So if you add all of those up, eventually it will get to 100. Right, sorry, it was DI 1 divided by 74, not 75, and there we have 1.35%. If we picked a different variable than make, for example foreign, we can see we no longer just have one of each value of make or of foreign. Here we have only 2 possible values for foreign, and so some of them are going to be one and the rest are going to be the other. We have 52 domestic cars in our sample and 22 foreign cars in our sample. Now it's worth noting here, remember, if we describe this, describe foreign, it's a byte, and if we summarize it, you see the min is 0 and the max is 1. So having domestic and foreign here is not telling the full story. Well, we can do tab foreign. We can also add the option NoLabel. And I can just shorten it to NOL, or you can include the full thing. It's up to you. What that does is it sort of strips away the labels that are applied to each of possible values for the variable, sort of like a mask that is covering what is truly going on underneath. And here we have 0 and 1. So foreign is actually dummy variable, either 0 or 1, and makes sense that if it's called foreign, then all foreign cars are coded as 1 and all non-foreign cars are coded as 0. If we do rep 78, tab rep 78, we can see that it's actually the repair record for 1978. We have the possible values 1, 2, 3, 4, 5. We do not have variable labels that tell us what each of these values means, though. And in fact, just looking at this, it's not particularly useful. We don't know what a 1, a 2, a 3, a 4, or a 5 mean for the repair record. And in fact, you can, if you are interested and willing to do it on your own time, you can find out what those are meant to mean here. But the point is that we're not really able to discern it on our own. And so this should be a lesson you do when you are creating data sets yourself or cleaning data and perhaps creating new variables. You want to make sure that you include a full set of labels that make sense of what you have created, both for you and for anyone else who comes to use these data in the future. Now, we said we can just type list and we're going to get absolutely everything listed. We can also, again, list just a few variables. as we did before, but now let's put a restriction on it. Let's use the conditional if. So if here, we can do a few different things, but let's say if rep 78 is missing. How we're going to do that is double equal sign, and you can either put a space or not after it. And we know that there are only 5 missing observations for rep 78, and so for each of those for which rep 78 is missing, we have listed make, miles per gallon, price, and then miles per gallon again. Now this is not the only way that we can actually deal with missings or kind of tell Stata that we're interested in missings. Instead of doing this double equals dot, we can also do mi, and then in brackets the variable mi for missing. If we do that, we get the exact same thing that we did by doing if rep 78 equals dot. If you do the equals, make sure that you do the double equal sign here. If you just try with one equal sign, it is not going to work. And that is going to be something that you struggle with occasionally with Stata. Sometimes it's going to want an equal sign, sometimes it's going to want a double equal sign. Here, this is simply a matter of you saying like conditional on rep 78 being exactly equal to period or a dot, and that's why that's important. When you're doing things like, for example, creating new variables, and you do generate the variable name and then you say equals and something, you would only want to use a single equal sign. There are going to be times when it's not quite as obvious to you, and you'll get the hang of it as you work with Stata more. Now maybe you don't want to show the make, miles per gallon, price, and again miles per gallon of cars which had missing repair records. Maybe you want to show those variables for the non-missing, or the cars that had non-missing repair records. So if we want to do that, rather than doing equals, we're actually going to do exclamation mark equals dot. And the exclamation mark is like saying not for Stata. So if you do that, it's like saying for any non-missing rep 78. And we can see that we get an entirely different set of variables here. And even though it says we're going down to 74, there are in fact a few missing. For example, observation 6 is not showing up here. So in fact, given that there are 5 up here that had missing rep 78, that means out of 74 there are only going to be 69 that were shown here. Doing exclamation mark equals dot is not the only way to do this. You could also, instead of doing mi rep, just put exclamation mark, not missing. And again, you get the same list. And we're just going to break that. And you can also use tabulate to essentially show a crosstab, so you can see how correlated, in a sense, 2 variables are, or the individual observations are for these variables. So, for example, say we did tab rep 78 in foreign. Then we have, for each of the different values of rep 78, we have, well, we know a total of 2 that got a value of 1 for rep 78, and both of those are domestic. We have a total of 8 that got the value 2 for rep 78, and all of those are domestic, none are foreign. But then we have 30 cars that got a value of 3 for rep 78, 27 of which are domestic, 3 of which are foreign. And doing this sort of thing gives us a sense of how things look in our data. In fact, it looks like foreign cars tend to have high values of rep 78, whereas the domestic cars are sort of about equally distributed on either side of 3 and concentrated at 3. We already went over NoLabel with tab, so we won't go over that again. Sum price miles per gallon of foreign equals 0. Great. So let's try that. So we're going to do if foreign double equals 0. We're going to summarize price in miles per gallon. And we can see that, as we saw earlier, there were 52 domestic cars in the sample, and that means if foreign equals 0, so of the 52 cars that are included in the subset of the sample that have foreign equals 0, we want to summarize, get summary statistics of price in miles per gallon. And here we can see that they don't look quite the same as if we looked at foreign cars with foreign equals 1. So the mean price of foreign cars is higher, standard deviation is lower, and miles per gallon are higher. Well, the standard deviation is also higher than for domestic cars. What if instead of being exactly equal to 0, for example, foreign, instead of being exactly equal to 0, we said, okay, well, let's do greater than 0. Well, we know that that means that foreign has to equal 1 because we have a full set of observations for foreign. We have all 74 observations for foreign, and foreign is either 0 or 1. So if it's greater than 0, then it's 1. So this is the exact same as just saying if foreign equals 1. Now you do have to be careful here because this is not always going to be the case. For example, if we did if rep 78 equals 1, but we only have 2 observations, that is not the same thing as dealing with, for example, foreign when we deal with rep 78. The reason is we have missings in rep 78. Remember those periods, those dots that were missing in rep 78. So let's, rather than just doing if rep 78 equals 1, let's say, okay, if rep 78 is greater than 1. Now remember we had 2 observations where rep 78 equaled 1. But remember we only had 69 total observations because 5 were missing. And yet we here have 72 observations of price in miles per gallon over which, for example, the mean standard deviation are being calculated, and the min and the max. And if we did detail, we'd have others. The reason for this is that Stata is going to treat missings as greater than 0. These dots are going to be greater than 0. And there are values for price in miles per gallon. There are observations for those, even for those cars that have a missing rep 78 value. And because of that, we may accidentally be including those cars in our summary statistics when we do not want to. For example, here we got if rep 78 is greater than 1, we got all these values, but what if we actually did not want to include these values of price in miles per gallon from the cars that had missing observations of rep 78? Well, let's add a and non-missing rep 78 to this. See now, instead of 72, we only have 67 observations. And we can see that the means have actually changed a little bit, and standard deviations as well. We don't have to worry about the min and the max having changed as a result of this, but we did not know that until we looked at it. So it is something to keep in mind, in general, that if you do a greater than operation on some variable that has missing observations, you are going to be including all of those values for the variables which are associated with those observations. So, for example, price in miles per gallon or whatever else we're doing, and you may not want to be doing. One more thing that might be worth keeping in mind, you can do greater than or equal to or less than or equal to 1, in which case we would include all of these. Again, it would include the observations for which rep 78 is missing. We get a total of 74. And if we do less than 1, we are not going to be including these missing observations. Less than 1, there are none, because rep 78 goes from 1 to 5, and the missings are treated by Stata as positive. Moving on to by sort. So you can do, rather than by sort, you could do by. If you type help by, for example, you get some description, but by sort is included right there. When you use by, you may actually be given an error. A lot of the time it says the data are not sorted right, I don't know what you're doing. In general, I would just use by sort. So if you use by sort, what are you trying to do here? Well, let's try by sort foreign and then do something. All that's really doing is saying, look, for each value of some variable, we want to perform this operation. So foreign we know is 0 or 1. That's domestic or foreign. So let's do by sort foreign colon, and we'll sum price in miles per gallon. Here pops up for domestic cars, we get the price, miles per gallon, summary statistics, and then for foreign cars, we get this. So this is nice. We don't actually have to type in individually sum price, miles per gallon, if foreign equals 0, and then type in again sum price, miles per gallon, if foreign equals 1. We can just do by sort foreign. We can get it for all of these. Obviously, this is useful for variables like foreign or maybe rep 78, where there are some limited number of possible values it can take. If you did it by price or by make, then you would just get the summary statistics of price in miles per gallon for every single car. So it would actually just be the values for each car. You can't get a mean that differs from an observation if there's only one observation. And it wouldn't be very useful. So you only want to do this sort of thing when you're dealing with variables that have a limited number of possible values. You may also wish to apply a conditional like if to this. So let's do that. By sort foreign. You can shorten it if you're interested. List price if price greater than 10,000. And let's do that again, but let's list price and miles per gallon. And now let's include in parentheses miles per gallon after foreign but before the colon. Now what this is going to do is not actually break everything down within domestic and foreign by miles per gallon, but rather it's simply going to sort everything within each of foreign and domestic on miles per gallon. So what we saw from what we just typed is that we've got these different prices and miles per gallon listed, but there's no order to either the price of the miles per gallon. Whereas now, if we type this, we can see that the observations have been sorted according to miles per gallon, going lowest to highest. Something else that we can do. We know that if we just summarize price, we're going to get this. If we do sum price detail, we're going to get this. But now we can actually type return list. we see that we have a set of scalars that have been temporarily put into Stata's memory, and it's all these values here. They've been put into a number of scalars. Now, as soon as you actually do anything else, like summarize a new variable, a different variable, these scalars are going to be cleared out to make room for the new ones under the same name. So you do want to make sure that if you want to use these, that you take advantage of them immediately after you have performed, for example, the summarize command, or you can do with later things we'll see regressions. You can do eReturn list. You're going to want to get anything of interest sort of saved away as you could do another scalar, or better, a local that you can later call. So we did return list. Let's save the average price. Remember, we summarized price, so the mean is going to be what we call an average price. So we can do local average price equals our mean. Now if we do di average price, we're going to see it's 6165.2568, which is what was up here recorded as our mean. Now if we do, for example, sum mpg return list, and keep in mind if we did not do the detail, then we're not going to have the full set of scalars, so here we get different scalars. But note that the mean, our mean, is now 21.29 because this is the mean of miles per gallon, not of price. But we can still call up the average price, which we saved as a local macro called average price. And we can then type things like, di, the average price of a car in our sample is, maybe we want to include a $, and then average price. You can also use table. You remember if we did like tab rep 78 foreign, we got something like this. I tend to do that sort of thing, but you can use table, which is not the same as tabulate, although it looks quite similar. Table rep 78 foreign, you're going to get this. It's not going to include the totals, but will include all of these here. And maybe that's something that you find valuable. Correlate. You can correlate, you can type the whole thing, correlate, or you can just core. Let's do core rep 78 in foreign, and you get this correlation table. So obviously rep 78 is perfectly correlated with rep 78, and foreign is perfectly correlated with foreign. We have a correlation coefficient between rep 78 and foreign of 0.5922. Maybe we want to restrict that if price is greater than 4,000, and you get different correlation coefficient between the two of them. Or maybe you are interested in getting the covariance rather than correlation coefficient, and if you do that, then you get a table of the covariances. Alright, the last slide for exploring data, we're going to look at histograms and kernel density plots, and then we're going to take a break. So, let us do hist or histogram, it's up to you. Let's do price. And we see what pops up. It looks like this. And it looks like the majority, or at least a plurality, of our observed prices are at the very low end of our distribution. Certainly the majority are within those first two bins that are shown, and then we have a long tail. Perhaps we don't want to do it quite like that. Perhaps we want to actually have more bins. So we want 15 bins instead of the number that we had. Well, when we do that, that's going to make smaller bins in order to have more bins. They're each going to be smaller, their width. And so it turns out that the price is still clearly, as we wouldn't expect that there would be any change. We're going to see concentration in the distribution at the bottom, but when we have these smaller bins, we can actually see, okay, a plurality of these cars are actually not in the lowest bin that's now defined, but rather in the second lowest bin, unlike before when we had more bins. And you can, of course, change that to 25 bins or 50 bins, whatever you like, but they stop becoming useful once you have too many. Maybe rather than having the number of bins change, you say, no, I want the width to be, say, $600, my bins. Well, and what that does is it is going to increase the number of bins again, and we get something that looks like that. You could make even smaller bins, but as I said, it stops becoming as valuable, starts becoming more noisy if you do something like that. Perhaps you're actually interested in, rather than getting density, you want to get the frequency, so the actual number of cars within each bin. And I often find this to be quite useful. If we do that, we can see, okay, there are about 35-ish cars in that first bin, about 21, 22 cars in that second bin, and so forth. Now, kernel density. Let's look at miles per gallon instead of price. Actually, let's keep looking at price. Why not? So let's look. Kernel density, K-density, price. So you don't necessarily have to, but if you have a variable like price where it seems to be more continuous, it may be valuable to you to look at a kernel density plot instead of a histogram. We can see it looks similar to the histogram in terms of its shape, although it's definitely smoother, which is what is going on with the kernel density plot. How does this compare to a normal? So are our prices normally distributed? Well, we can just tell Stata we want the kernel density plot of price, but we also want you to overlay a normal plot, at least as far as the values of price within our sample allow. So cuts off on the left-hand side at the lowest price, then we can see that would be a normal distribution of price. Clearly, our prices are not normally distributed. So that's a basic introduction to exploring data. A few commands that you can do to see different things, either just seeing it in tables, or seeing certain values, or visualizing data. And anytime that you have a new data set, you are going to want to explore it first. As I said, you really want to understand, for example, if there are missings. You also want to understand approximately how the data are distributed and how they might be correlated, etc., etc. This has introduced you to just a few of the ways that you might try to do that. So let's now take a break. And when we come back, we're going to have some fun learning best practices.